Party started. So last time we were looking at this binary print. I think we got our justified printing to work. So if we... Not sure why my chat is not working. Oh well. But let's see if we can get it to work. So... Here, I think this is our justified size. So if we pick something like 8... We get 8 characters, so we did get our justified size printing. So then, let's see. So, I think 4 is going to be what we want. Chat. Let's see. Will chat work? Hey, there we go. Okay. So our justified size, I think, is 4. So if we're just doing 1 byte, we should be able to have a space. If that's what we're going to use. Here we used that. I think 20 hex is a space. Yeah. All right. So I think just we need to do the numbers we're doing in. So if this is 64, print 64. So then I think we just need a loop here to... So let's see, our RDI is our first argument, so that's the number that we want to print. We will pick a register to throw it into. So let's pick R12 to get RDI. We want to AND R12 is 0xFF. So that should just give us the bottom byte. Okay. So what we want to do is we want to take this top bit and we want to... So if we do an AND of RDI and R12, that will give us if that is set to a 1 or not. And then compare RDI to 0. Oh, let's try a conditional move. So if the 0 flag is set, if the result is a 0, we want to move into RDI. Well, it's already 0. So if it's 0, it's 0. We can just print off a 0. Sounds good. If it's anything other than 0, so not 0, we want to move into RDI, the number 1. we'll just print off a 1 or a 0. So then we should be able to call print justified. Like we do here. So these should be for the top line. Actually, we'll just move these up here. So RDI is our number, is a 1 or a 0. Print justified for the top line. And then what we want to do, so that should it sets it up in the buffer, but it doesn't print it, right? So we print the top line. Yeah. So this is really like append justified. Should be what it should be called, because it's not printing anything. So then we need to just use the number. So actually, we could probably just do it here. Save our registers. I don't think I'm using RSI for anything. Okay, so push our registers. We did our AND. So this will be the numbers, like 128, 256, whatever. We can then call print justified with the top. No, this will be the bottom. For each of those. So we'll add them to the bottom buffer. And we need to pop R12, pop RDI. So restore them. Compare it to 0. Right, so we just restored it. If it's not 0, move a 1 in there, and then we'll print off. So that should do both of them. And then we need to call this with our number. So here we got 24. Let's pick 128 and see if it should get set. Line 68. Mandela combination of opcode and operands. That's fun. Let me look at my, I had an example. Zero and not 0. Z and not Z. Oh, do I need to register? Oh, I probably need to register. I may not like an immediate. Let's see, does it like that? Okay. And there we only printed one line. So if we go ahead and do the top line and then hey, we got a 1 and we got 128. So now we just need to keep doing this. See, our mask is in RDI at the moment. We have R12. so let's use R15 for our, well, so if I jump back up to here, RDI, compare RDI. Let's see, it gets a mask here. Let's use RSI. Move RSI. Well, we're gonna save something. R15, 0x80. So that's our mask. Save it on top of the stack. Pop R15. Pair R15 to the number 0. Jump greater than or equal to top. There's my label. And I think that my stack is probably off. Yep. I do a push. What else should we save? R12, RDI. That should. What is push? Pop RDI. So if I don't use that, where's R15? I got three pushes. That's 4. 1, 2, 3, 4. We pop it. Maybe I can fit all on one screen. Pop. Every time I push it, I pop it. Yeah. It's working before. Let's see. Well, if we debug it. What's our stack trace say? So do next. That's like an invalid. What's R12 got? And maybe it's going forever. Oh. Oh, it is going forever because I didn't decrement my counter. Well, that was not smart. Sub R15 1. Actually, so I don't want to sub 1. I want to shift right by 1. Right? Debug, run. Again. Jump, not 0. Alright, so I picked a 128. Let's see, 127. Yeah. Now, this, that's interesting. So, I got a, let's pick 100. So 100 is 0, 1, 1, 0, 0, 1, 0, 0. So we got a 4, a 32, and a 64. I guess it depends on what we want it to look like. You know, do we always want to print off all of these, or do we want to print a space? I mean, I guess it sort of depends on what we want it to look like. I mean, so but why is it so it's printing off a 0? Oh, because we do the bottom first. So if we do an and, and RDI is what we're doing. If we do that, no, not R12, and RDI R12. No, this would be R15. R15 has our mask. So, I don't know. Anybody have any? I guess I got one viewer. Got an opinion on which one you like better? Should it print off zeros, or should it just print off the numbers we want? And we only did 8, but we could certainly do 16 bits. Although our space needs to be at least 5? Or is it 6? I think it's 6. 6 seems better. There we go. So now if we call it with an example. Bits, and you could do a hex print as well. What do we call that? Print bits. Yeah. Print our bits. That is an extern. Oh. Print. Why did I call it that? Oh. Bad name. Bad name there. Yeah, so we can print off our 128 bits and we can see Cafe Babe, and then we can print off what is our binary number. And we see that it has each one of these bits on which one is set, like 132,768, 181.92. So that seems good. And so like this SNPrintf, use SNPrintf. So it's just putting it in the buffer. So if we wanted to turn them into spaces, you could put a space in there. You could just say if it's a 0, we could print a space, but anyway. But hey, it works. That's pretty neat. So I guess as long as, as long as we pick the right ones, like we could set the mask in the initial call, but seems like this will work. I think that seems good. So RDI will, we can use it in either one. Okay, that's not for you, Goober. I'm interrupted. All right. So what should we do? Like our print bits does that nice 64 bits. And we could do bigger, but like it's gonna be unwieldy when you start printing off. What's 2 to the 64 minus 1. Like, that's just a lot of digits to print. So I think I mean, I guess we could have a couple different calls to set the mask. So I don't know. This seems fine. I think that will work. I mean, right now we're using RDI. We could use RSI for our mask, and then you'd have to have more arguments when you go and call it. Most people are only going to want to look at the binary for like something small, because adding them up, generally I would actually just use 1 byte. So I would probably do this, because I think that is mostly what somebody would want to look at, 1 byte. And so if we go and look at a byte, and then we can set our this number to, let's say a 3? No, F4. So for that binary number right there, that's our result. I guess let's say 2 to the 32. That would be terrible. That's 4 billion. 3, 6, 9, 10. So our spacing would be 11 spaces per item to make them equa-spaced. I like them being equally spaced. And when they're not, it's I think more difficult to read. Because this is a binary number. Question is, what it'll look like. So FF, FF, FF. 1, 2, 3, 4, 5, 6. Our justified size would have to be 11. And it won't fit on my screen. Also, it was a signed versus unsigned. The int format is doing signed. Oh, so my last one turns negative. Yeah, let's stick with a byte. 1 byte. From 11 to 4. So BE. And honestly, our print bits, we could, you could pick a smaller mask. Question is with that. Yeah, that messes it up because it's assuming that, yeah, the mask is clear up there. We would have to do, that, I think. Yeah. I think that's good. You guys have any requests for now or in the future? I mean, nobody's chatting yet, but if you guys feel want to. Probably at some point we'll do the floating point, print off that. Or look at something like UTF-8 and what the bits are, and I was looking at that earlier. So, well, I think we got the binary print. You guys decide. Decide you think there's something fun. Decide you think there's something. We can definitely do it. Okay. So we got a binary and hex printer to work. So I think we can put this. So print binary int print. We'll do 1 byte. We can put this in. We solved our goal. It's always good. Oh, and what formats did it use? So we had. Did I use the string format? Not sure. I knew I used those. Let's copy them all. Alright, so data, BSS. There's my text. Okay. Should make a nice BSS. Gotta export it. Binary print in int print. Binary int print. R include. And then here. That's external now. Okay. Remove these. My smprintf puts is new. Put car I already had. There we go. That part worked. Well, did it? Call binary int print. Oh, I need to get rid of those. Oh, yeah, they are defined. Ah, they are defined. Actually, I should just put those in. Because I actually want to call them. I want to do all of this. So I want to put it down here. So do my prologue. Epilogue. Now my top line and bottom line are contained in this file, so they don't have to be. In the other one. So instead of exporting binary int print, we'll just export binary print. And they include binary print. Huh. So they're not getting printed. Why is it not? Why am I not sure why that is getting called there? Oh, I'm not calling it. That would help. And in my main, I should print a new line. There we go. Oh, and I guess I had some code probably in my main. Yep. When I was testing smprintf. Which I don't need that anymore. Just call ASM main. I mean, it would have been easier to do that all in C, although string manipulation in C is notoriously a pain in the butt. So, all right. Well, I think I will. Let's see. Let's open up our template. And our io.asm fixed my print new line there. That was exciting. Put those in. Here's my print new line. Oh, I got rid of my change. Oopsie. Whoopsie daisy. Let's undo that. This is my new print NL. Save some registers that ended up getting clobbered. Just recording a video and realized that some of these got clobbered when doing that. Alright, so this should be our new one. So I should have some changes here. Print new line. And then this giant function we added. So now our changes are what do we call it? Binary print and fix new line. Push to main. Alright, I'll be in all new projects. We'll be able to call those. Next time we'll look at the floating point. So when you define a floating point, so if we go to Godbolt, and we pick a double, so it's actually using XMM to do it because it's 64-bit. And there's a constant in there, which is not seeing it in this disassembly, but it's definitely in there. So we should be able to print off what is the sign bit, the mantissa, IEEE 754. One guy that has a really good view of it. This also will. So we got 1 bit for the sign. We got 8 bits here for the exponent. And then we got 23 bits for the mantissa, but that's in a 32-bit, so 64-bit. We get even more bits for storing that. 11 bits for exponent and 52 bits for the fraction. So that'll be fun to print off. Although I think mostly you just want to print the bits, and that can help you sort of parse it out. But that would be as you can see, right? Like, I think this is the closest representation that you might get, other than also showing the binary value that's associated with that. So, but why don't we'll look at that next time. Hey, hopefully you guys enjoy it, and we'll talk to you later. Thanks.